This time we're given an infinite geometric series. It has infinitely many terms being added together. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... forever. Okay, we're asked to find the sum if possible. If it's not possible, don't bother. We're not going to take an answer like infinity or negative infinity. No, we need a real number solution. So let's check to see if it's possible first. We do that by first, step 1, find the common ratio r. Now they told us it was geometric, so we can take r equals any term a sub n divided by the term before it, a sub n minus 1. Any of them. So let's see, let's take 1/2 divided by 1. That equals 1/2. So the common ratio is 1/2. Now, let's check to see if this sum exists, if we can actually use this formula. Does the sum exist? To find out, we must show that the absolute value of the common ratio is smaller than 1. I don't care if it's negative or positive. I just want the absolute value to be smaller than 1. We'll check. The absolute value of r equals the absolute value of 1/2, which is equal to 1/2. That's smaller than 1, so yes, the sum really does exist. Okay, yeah. Now, I told you why. The reason why is because if the common ratio is a number between 0 and 1, each time you multiply and get the next term, multiply and get the next term, they're getting smaller and smaller and smaller until they become totally insignificant to the sum. So we know we're not going to be adding up and getting an infinitely large sum. Okay, anyway, the absolute value of the common ratio is smaller than 1, so yes, we can use the formula to find the sum of these infinitely many terms. Step 3, we're going to find the first term, a sub 1. Okay, a sub 1 is just, look at the list. The first term that's being added, a sub 1 is equal to the first term. That means that a sub 1 is equal to that number 1 that's listed in the given information. Okay, finally, step 4, we can apply the infinite geometric series formula for the sum of infinitely many geometric terms. That formula, you recall, is capital S equals a sub 1, the first term, divided by 1 minus the common ratio. Let's plug our values in. It's equal to 1 over 1 minus 1/2. Get a common denominator on the bottom, so it's 1 over 2 minus 1 over 2. So our sum is 1 over 1/2, but dividing by 1/2 is the same as multiplying by the reciprocal, 2 over 1. So it's 1 times 2 equals 2. Isn't that crazy? It turns out that if you add these infinitely many terms of a geometric sequence together, your answer is going to be 2. Crazy. I mean, it would have taken forever to do it by just adding with a calculator. I mean literally forever because that list never ends. This is the only way to get the sum.